Good morning, everyone. How's it going? Have you ever run out of Codex or Cloud Code tokens midday during your working project? Well, what I'm going to do today is I'm going to show you how you can use Kimi K2.7 or any open source model to improve your cost to quality ratio. And what we're going to be doing is we're going to be exploring how different combinations of open source models and closed source state-of-the-art models can boost your cost quality ratio without losing in any quality, as you can see right here. I have the data to back it up, and I'm going to show you how you can run this kind of experiments yourself with your own GitHub issues so you can select the workflow that you prefer. So without any further ado, let's get right into it. All right, so let me tell you a little bit about this experiment and what I mean when I say using multiple models during your workflow. So what happens is that when you have your task, your coding task, it can be an issue that you have to fix, it can be a new feature, etc. You usually go through many different phases, even if you're using the same large language model, right? So you have to first understand the issue. Then you have to explore the code base. Then you have to run an implementation plan or create some sort of plan of what you're going to be doing. Then you're going to have to actually implement the changes that were in your implementation plan and then do some code review. And what happens is that if you're using something like Codex or Cloud Code, you probably are using the same large language model for every single part of this workflow. And what I'm here to tell you is that you do not have to do that, because if you use multiple models in this workflow, it is possible to reduce your costs and to save those very valuable tokens from your most expensive subscriptions by using open source models in your workflow. And what I figured is that we can split this workflow into two different parts. So the first part is going to be kind of like the exploration and planning part. So we're going to have one model do the understanding of the issue, exploring the code base, and creating a plan of what we're going to do for our coding task. And then we're going to have another model do the implementation itself. And the code review is really independent because you always do it anyways. So we're just going to split this part right here. And we're going to have one model do this part and another model do this part right here. And the model that we're going to be showing today is Kimi K2.7, which is the new state-of-the-art model by Kimi, which was released right just over the weekend, which has wonderful coding abilities. And we're going to be exploring where in this workflow it fits best to improve our cost to quality ratio. Okay, so before that, let's actually take a look at what Kimi has to offer, because it really just came out a few days ago. So let's see what this new Kimi model is about. All right, so very quickly, let's take a look at the Kimi K2.7 Code model, and it is a specialized model for coding, as you can see right here. Something worth mentioning is that if you're using Kimi for any use cases, and if it's not for coding, then you probably want to use Kimi K2.6 since it is a more generalist model, but Kimi K2.7 is specialized in coding, as we're going to see in just a moment. So first of all, let's take a look at the very quick benchmarks right here. So on coding side, it is a huge improvement on Kimi K2.6. It lands way closer to GPT 5.5 and Opus 4.8 on their own coding benchmark, on Program Bench and MLS Bench Lite, and on their agentic benchmarks as well. So on KimiClaw, which is the benchmark that measures how good this model is at Claw-like agents such as OpenClaw or Hermes, on MCP Atlas and MCP Mark Verified, it's also landing much closer to GPT 5.5 and Opus 4.8. So as you can see, we have a model that is almost there, almost up there with this state-of-the-art closed models. However, and something even very, very fun to see is that it's much more affordable than these other two, as we're going to see in just a moment. But before that, let's take a very quick look at the model architecture very quickly. So it is a mixture of experts model with 1 trillion parameters and 32 billion parameters active per token. Its context window is 256,000 tokens, and it is natively multi-model as well. It definitely looks like a huge improvement on Kimi K2.6, especially on coding tasks, as you can see right here. And as you can see, they actually say that Kimi K2.7 is purpose-built for coding tasks. For general purpose work such as writing, analysis, and conversation, they still recommend that you use Kimi K2.6, okay? Now, let's take a very quick look at the pricing right here. And as you can see, the pricing is just ridiculously lower than GPT 5.5 and Opus 4.8. And this is exactly what we're going to take advantage of when measuring where to put this model to improve our cost to quality ratio. So as you can see, its input price, it's 95 cents per million tokens, and its output price is $4 per million tokens. And on cash hit, it is about 20 cents per input million tokens. And let me show you a very quick plot that I have right here of the comparison between this and Claude Opus and GPT 5.5. It's ridiculous, as you can see right here. So on output, Codex GPT 5.5 on million tokens is at $30, while Kimi is at $4, as we just saw. And Opus is at $25, while Kimi is at $4. Same thing for output. Claude Opus is at $5, just like ChatGPT. Just as GPT 5.5, and Kimi is at less than $1, as you can see right here. So huge difference, and this is what we're going to use, because we want to use a model as good as Kimi K2.7 for coding and use it together with GPT or Opus to have the lowest possible cost without sacrificing in quality. So that is what we're going to be doing today. Okay, and what happened right here is the following. We have already effectively split our workflow into two different sections. So the first section is going to be one agent. It's going to be the implementer. And this agent is going to be in charge of exploring the code base, figuring out what the issue really is, creating an implementation plan, and handing out that implementation plan. Okay? And then for the second part of the workflow, we're going to have another agent with another large language model that is going to implement the changes that are described in this particular, plan right here. And here, well, this basically begs the question, how do we know which LLM or which agent to use on which one of this? Should we use Kimi as a planner and GPT as an implementer, or should we do it the other way around? What actually gives us the best cost to quality ratio? And it turns out it's not that straightforward. Like you may have some idea, but I wanted to actually put some data into it. And just to be clear, this is not a completely scientific experiment. This is just a single run on a single GitHub issue. But I did devise a very quick test right here to figure out what could be the best approach to do this. So what I did is I found a fairly nice GitHub issue that is pretty recent. So it's this one right here. So it's a class scope comprehension with lambda raises system error issue on C Python. Okay. And as you can see right here, it is from just a couple of weeks ago. Here's the bug description. It's very straightforward. Feel free to pause it and even go look at the issue if you feel like taking a look at this more in detail. But it is very important that it is a recent issue to be sure that none of the models involved in the testing that I'm going to be doing right here have seen the issue before in their training material. Okay. So since this one is from just about 2 weeks ago, it is perfect to test how good these models are at this. So I take this GitHub issue and I gave it to all of my models. So to Kimi K2.6, to Kimi K2.7, GPT 5.5, and Opus 4.8. And I had every single one of each create a plan, explore the code base, figure out what the issue actually is, and create an implementation plan for this particular issue. And then that plan of each one of them, I gave it to each one of them as well and asked them to be the implementator. Okay, so each one of them had to implement the plan from every single one of them and produce a solution with that plan. Okay. From that solution, I had my judges evaluate the solution, and the judges in this case were the two state-of-the-art models. So it is GPT 5.5 and Opus 4.8. I could have selected a single one, but I wanted to mitigate some bias between the two of them actually preferring their own model coding. So I put both of them and then just averaged the score. And at the same time, I measured how much each solution costed. So how much was the key Kimi as planner and Opus as implementer costing, and how does it compare to their average score. Okay, so that is the setup. Now, here's where the results are going to come, and we're going to see which combination actually gives us the best average score and which one gives us the best ratio between the two. Okay, so let's take a look at the results right now. All right, so let's take a look at the results. And just before that, I just want to make this very, very clear, is that there is going to be quite a bit of noise in this because this is not a completely scientific experiment. Because I am doing this on a single GitHub issue, and it is a single run on a single GitHub issue. So there's going to be a lot of noise. If we wanted to make this much more scientific, if you wanted to actually turn this into some data that we could present to defend a thesis, we would have to run this multiple times across multiple GitHub issues to actually see the tendency and the trend of different combinations. However, I feel that a single run still gives us shed some light on the tendency of which models compare the better. Okay, so as you can see right here, all of the Kimi combinations cluster right at the left. And just to make sure that things are clear, the x-axis right here is the cost. So the closer to the left, the better. And the quality right here goes from 0 to 10, and this one is on the y-axis. So the higher, the better. So the better value comes from being closer to this little corner right here. And as I was telling you before, there is going to be quite a bit of noise because this is a single run, and every single combination that we tested right here actually managed to get a solution and to create a mergeable PR for this repository. So we could say that the quality of pretty much all of them is pretty much the same, because as you can see, there is about a 1-point variance between all of this in a 10-point scale, which is pretty much nothing. So if we assume that the quality is pretty much the same for all of these runs, then the real differentiator is the cost. So we can see that all of the Kimi models cluster together at the left, and these combinations that use Kimi are about 7 times more affordable than the most expensive combinations right here. So as you can see right here, Kimi K2.7 solo, in other words, Kimi K2.7 being the planner and implementer, gives us the best cost right here, followed closely by Kimi K2.6. And actually, we can see that the combinations with GPT 5.5 are the best right here in cost performance, followed closely by Claude Opus being the planner right here. And we had a little bit of an issue right here with Claude Opus planning on one of the instances, but as you can see, just adding Kimi to the mix makes you save a ton of money. So in my opinion, my particular preference in this case would be to use GPT 5.5 as a planner and Kimi K2.7 as the implementator. Let's take a look at the actual cost breakdown right here. So as you can see, Kimi K2.7 spent about 30 cents in the whole thing, Kimi K2.6 as well. And as you can see, the different combinations ended up being not that great. In this particular case, we see there is a little bit of noise. So Kimi K2.6 and Kimi K2.7 performed relatively similarly because this is a relatively simple issue. But when we used Kimi Opus, for example, to do everything, the cost just went over the roof. And when we used Opus and GPT 5.5, that was just the most expensive combination that we could find. Opus and Kimi also gives us pretty good cost, and GPT 5.5 is surprisingly also quite affordable, but nowhere close to putting Kimi in the mix. However, I do seem to see a clear tendency right here, which is that Kimi is working better in these examples as an implementator, and the most powerful state-of-the-art models such as GPT 5.5 and Opus are apparently the best at planning, because they are going to be taking a look at the entire architecture, understanding the code, and creating a detailed implementation plan that is then passed to Kimi, which is great at implementing the whole thing. So if you have a little bit of a more complex issue, I would advise you to use GPT or Opus to run the planning stage and exploration stage to understand what the issue is, and then have Kimi implement those changes. Okay. And here are some other takeaways. So Kimi K2.7 is the new value king. As you can see, it is even more affordable than Kimi K2.6, because if you have used Kimi K2.6 in the past, you probably have seen that Kimi K2.6 is a bit verbose. And Kimi K2.7 is less verbose, albeit it being just a tiny bit more expensive. It's really nothing, about 5 cents more per million tokens on input, and the output is pretty much the same. And Cloud Opus 4.8 is a strong planner, but quite an expensive implementer in this particular run. And GPT 5.5, pretty consistent mid-range cost with pretty good results. And if you want to take a look at the bias of each one of my models that I use for judging, you can take a look at the blog post that is in the description. Again, to be completely clear, this is a single run, not a scientific experiment. This is not engraved in stone that GPT 5.5 is always going to be the best planner, or that Opus is going to be the best planner, etc. This just gives us a tendency, and the clear tendency that we have seen right here and in other also experiments that I ran behind the scenes is that putting Kimi in the mix is going to improve your cost-quality ratio, make you spend way less, save your very powerful tokens from GPT 5.5 or Opus without sacrificing in quality. And my specific recommendation is to use either GPT 5.5 or Opus 4.8 for planning and Kimi for implementation. Let me know if you want to see similar examples of combinations of these models, and I will probably be presenting them right here in the channel if you're interested. And also, if you want to run this benchmarks yourself on your own GitHub use cases, there is a skill that I created that you can already start using. Let me pull it out right here. The link is going to be also in the description. It is called DuoBench right here. And as you can see, it is a skill that you just install with npx skills add, and you just ask your model benchmark Opus and Kimi on DuoBench and produce plots about the results, and it will give you similar plots to what you saw right here. It uses Pi through RPC behind the scenes, so you're going to have Pi installed and the models that you want to use configured in Pi. But and you have to have Tmux installed as well. But other than that, you should be able to just run this kind of benchmarks on your own machine if you want to. All right, so there you go. Kimi K2.7, great model. Thanks a lot for watching, and I will see you in the next one.